Okay, so everybody, welcome to the second day and the first session of the second day. I'm Keith Blackwood. I'm a freelance full stack engineer, basically medical adjacent. I've worked in tissue engineering and regenerative medicine, and I have a PhD in that. But I'm not actually a medical doctor, so I'm more from the coding side. And so this session's a bit of a nuts and bolts session. We're talking with Clinicians-Who-Code, and we're going to start with Marcus, who is just running out of scene, and he's coming back in. So without any further ado, let's start with Marcus and his topic.
I'm going to talk about clinical safety. I think we can do it a lot better than it's currently done. So I'm a GP by background. I have before that, a previous life in hospital medicine, and then I became a clinical informatician and then started coding a bit, and now I code a lot. And over that time, got quite familiar with the tools that people use for writing code, which solve a lot of the problems we have in medicine. And this is one of them. We need to be able to manage documents and artifacts, knowledge artifacts, over time with multiple contributors. And they already have tools for that in the software world, so we don't need to invent any new ones, we've got them. So let's talk clinical safety. That's me. These slides are online. I'll share the link at the end. But clinical safety should be better. So this is what we do currently. It's a documentation-heavy sort of thing. Here we go. My journey to becoming a clinical safety officer is the same as everybody else's. You go to the website and you find out what the training is like. This is the clinical safety documentation. It's all on NHS Digital's website. And you go on a practitioner training course and you learn the sort of standard approach to clinical safety, which is to write a lot of documentation and look at the hazards. So, am I close?
Put that in a better place.
Yeah.
More central. No, then it will work.
Okay, is that better? Right, sorry about that. So that's how you become a clinical safety officer by going on some training, and then you become the clinical safety officer for whatever product you're in charge of. In my case, that was the digital growth charts for the Royal College of Pediatrics and Child Health. Hang on. So then you learn about the things you've got to do. So this is filling in a Word document for your clinical safety case. And this is where I started to diverge, and I was thinking, this can't be. This is it. This is how we do it, right? This is the best way. And then even worse, we put a hazard log in an Excel spreadsheet, and I was completely baffled at this point. I was thinking, no, surely not. Then you hide it in SharePoint, and no one ever looks at it ever again. No one can see it. And so I was thinking, okay, well, maybe there are better places, like places that have nailed this. And there probably are, but they keep it to themselves, completely secret. There will be consultancies who've got an internal process that is better than this, but they won't tell anyone because that's the secret source, right? I actually was working at Anaesthetist Digital at one point on GP Connect, and so I was involved in what do they do? Excel spreadsheet, hidden in a SharePoint, and loads of documents that no one ever looks at. And they're not something that you can publicly peruse either. So we lack all that transparency. What's the point of a risk register, which is what a hazard log is, right? If people can't see it and look at it and say, hang on, what's this hazard here that's unmitigated? It's possible when you're closing everything down and hiding it in your SharePoint, you can hide in there a lot of nasty, a lot of stuff that should be mitigated, a lot of tech problems that could be fixed. And there are some unfixable things that you can't fix with a technical mitigation. But it's important at least to be transparent about those things. Now you've lost my focus, whoever was sticking with the mouse. Can I have it back, please? Thank you. So it turns out the rest of the industry use the forum that I run, Digital Health Networks, and they go on there and they'll ask, has anyone got a clinical safety case for Attend Anywhere or AccuRx or whatever it is they're implementing? And there's no like sharing platform for these things. Not only that, even if there was a sharing platform, they're sharing Word documents and hazard logs in Excel spreadsheets. So you just got to start again, haven't you? I mean, I probably don't need to go into much detail about this, but like doing all the documentation in Word is kind of stupid when we live in the internet era. And so it's very documentation heavy. You get a template from the NHS Digital website. That is still what you do. I checked like this week, and like the template is a very big Word document that you essentially manually find and replace, like your clinical safety officer's name, and you do the version control manually. So there's a box, a document control box on the first page, and you go in there and write people's names in. And if someone forgets to do that, then that's fine. And if the last version is clearly not the same version as the one you've got, and the document control is totally at odds with the file name that says, you know, like final 1.2 brackets, use this docx, then that's also fine, it seems. But the thing is, like, software has all this solved. So you've got version control tools in software that do this for you, that sort out the attribution, that sort out the date stamping, that sort out the diff and the changes. You can see exactly what changed version to version. So we should be using that, right? The hazard logs in an Excel spreadsheet is frankly unsafe. Top line is that you can easily delete an entire row, like when your cat walks across the keyboard, and that hazard never happened, you know? Other more operational things is like, you have one row is one hazard, and as you go along, there's kind of like describe the hazard, and then you say how bad it is, and then obviously you've got to artificially inflate how bad it is at the start so that you can then reduce how bad it is a bit further along in further columns. And then if you really want to do hazards, you want to be able to like have some back and forth discussion, involve other people. What are you going to do? Add a new column for like, and then reply from a clinician is a new column, and then technical people reply and there's a new column. It's just, es un tontería in Spanish. It's madness. So it also means your hazards are like nowhere near your software development process. And the tech people have tools for this. They've got bug trackers, okay? And essentially a hazard is a bug, right? We can wrap it in UI, things that make it look nicer for us clinicians and things, but it would be great if they've got bug tracking over here for managing the software, and we've got hazard tracking. If they're as close together as they can be, then you could have a hazard that's identified, you manage that with software changes, and then you can quote the actual software changes in your mitigation and say, this is now less of an issue, less of a hazard, because we made these code changes. It might even be as simple as like we moved a button from here to here, so it was less easy to accidentally, you know, prescribe the wrong thing or something. But that code change can be linked into your hazard, and then you've got evidence that you actually did mitigate it instead of just like, sure, we did. I have a problem with not publishing clinical safety cases, and I know that I'm probably the only person in the country that wants to publish my clinical safety cases, but why are they hidden? Why are they behind firewalls and, you know, NDAs? You know, there's quite a lot of very, very toxic commercial activity around this. So, you know, you can be implementing a piece of software in a trust, and you'll have to sign an NDA before you can see the clinical safety case and the hazard log. Definitely true. If you search digital health networks for clinical safety cases and read some of those threads, there are some horror stories about essentially using the defense of commercial sensitivity to prevent us doing our clinical safety job. And I wouldn't want to be in court at any point saying, why did the patient die, Dr. Bohr? Well, we didn't really do a full clinical safety job because commercial sensitivity. You're going to jail. You know, we are the ones with the clinical responsibility here. We're clinical safety officers, and we should stand by that. It's not easy to do that, and I think we need to stick together, if we are clinical safety officers, as a community to make that point. You can't peer review a hidden clinical safety case. So there's lots of reasons why I think if they were published, we'd have much more transparency about what is wrong with these systems. The other thing is, if you implement a system in 50 trusts, and each of those trusts finds the same hazard and thinks it's a problem, and hides it in their SharePoint, so we have 50 clinical safety cases, DCB 0160 implementers clinical safety case, and that's 50 trusts think that's a problem. The manufacturer will probably say, well, you're the only one who's got that problem. We're not fixing it. But if that was on a public site and there were 50 different trusts saying that's a problem, it would be a lot harder for the manufacturer to argue that that's something that they, nothing to see here, go away. Because it would be very apparent that there's a real problem with this software. We can't see any of those problems. We keep getting promised that the new, I've forgotten what it is, PSIRF or something like that, PSIRF, is going to do all this. I confess to being extremely cynical about anything that NHS England tell me they're going to do, because I've never seen any of it happen. So PSIRF will not do this to any appreciable degree. I like this quote, which is, daylight is the best disinfectant. Okay, you put the stuff out there in the public domain, and then we'll see who's got a safe system. So I want a safety process that actually makes things safer, if possible. I want it to be close to the code itself. Sorry, the microphone is pointing entirely the wrong direction. I want it to evolve with the software, and I want it to be transparent. And this is cool. I want it to be able to federate my clinical safety cases and sort of share them up and down. So I'll show you what I mean by that in a minute. This is what I did. So I absolutely refused to do a hidden SharePoint Word document garbage mess. So I used GitHub issues for my hazard log, and it works very well. So you can describe the hazard. I have a template for that. And then you can use tags or labels, as they're called, to do your risk sort of stratification and work out a score for it and stuff. And then you can have discussion, and you can link it to code changes that mitigated the stuff, mitigated your hazards. This is the clinical safety documentation. It's not coming across very well on here, but you can see my clinical safety case report, hazard log, DTAC, medical device, because this is a medical device. And this is all in a documentation framework called Material for MakeDocs, which is free and open source. And all the source information is in Markdown, which is a very simple sort of text format, basically. And that's in a GitHub repository, right next to the code that actually runs all the digital growth charts. So we've put this publicly, and whenever people ask me, can we have your clinical safety case? I just say, yeah, it's all online. Just go there. And the navigation at the top shows you all the other things that's on there. So we've got our legal, technical, contact details, the commercial stuff, and all that. Git for version control and attribution. So we don't have to do the document control box that's always out of date. GitHub, using issues there, but we don't have to use GitHub. Obviously, it's owned by Microsoft now, and it ties us to a platform. We're working on getting the issues out of GitHub issues and into essentially a text format as well. Markdown, material for MakeDocs, and then publish the damn thing. That's the most important thing. So my next step was I had to do something else, another project, and I wanted to use all of that. So I thought, well, if I want to use it, I'll make a template so everybody else can use it. So on GitHub, there is this template repository. Anything blue here is a link. So when I share the slides, you can sort of follow the links if you want to. And what it does is converts the entire NHS digital clinical safety template stuff, all the Word documents, I convert them into Markdown for you. And where you can see the red boxes is templating language. So those get replaced automatically. And all you have to do is fill in there's one file in the root of the repository called make.docs.yaml. So if you put the clinical safety team name, which in this case, the default is clinical safety team name, then that's what will happen. You see where clinical safety team name appears? That's because I put it in that text file and it replaces it everywhere in the whole thing for you. So now you, with about, I don't know, 10 clicks, you can get from nothing to that document online published on GitHub pages. And we're using all the things that software teams use, and you know, we're hooking that all into our clinical safety work. If we wanted to federate it, what that looks like is the idea that if I've done a really good clinical safety case at local level, and then my ICB says, we want to use that for everywhere, they could just, using this, they can take the entire repository and make a fork of it, and then they've got a copy that they could distribute downwards. So regional level, up and down, or national level. So imagine a world in which a piece of software that, say, NHS England know is being used everywhere, they could produce the clinical safety documentation at national level, and everybody else just has to take their own fork and they can specialize it with their own sort of local specializations if they need. Because you know, it's not just having the documentation, you have to have the clinical safety reviews and that sort of thing. You have to involve local teams and your clinical safety officer locally. But at least you've got something, like you can start with a template from national level or regional level and pull that down. So this is like a way of reducing the total amount of work done, because a lot of it is really just wasting people's time, just filling in Word documents. We want to make this meaningful. The documentation should be quick and easy to do. Then you get onto the actual process of doing clinical safety, which is not writing documentation. But it's too techy, isn't it? All of that, a bit too techy for most people. But we're working on it. So my next step is to, all of that is public, and if you want more information about it, you know, hit me up on, I don't know, something I use, Blue Sky. I am on LinkedIn, but I don't use it. What we're looking to do next is wrap all of that process in a much easier layer, so you can just like click on it and say, I want one of those. So you can start with a generic DCB 0129 or 0160 and make your own brand new clinical safety case. But more commonly, what we'd expect is that you'd take somebody else's DCB 0160 for, say, Attend Anywhere, and just pull that down into your organization. So if everybody's sharing their clinical safety cases, then you can borrow them, can't you? And in return, they get yours. So this is how open source works. You know, we all benefit from the sharing process. Plus, by making them more public and making it easier to publish this stuff, I hope some people would want to go, you know, more public with their clinical safety cases, which again, it makes us all more honest. Turva is the platform that we're building that will do this. Soft launch of something we haven't built yet, but Turva is safety in Finnish, because Mark's part of the team, he's half Finnish. We came up with this idea when we were in Finland with a whole bunch of people. And so that's what we're working on, the idea of making this essentially an open source platform that will allow you to do all that stuff that I just said, but without having to be technical and having to end up, you know, digging around in Git and messing around with version control. It will still be doing that, but it'll be doing it for you. That's it.
Okay. So thank you very much. Just moving straight on, we've got Kieran, and Kieran will be talking about impressive, published, but useless. So I'll let him fill in the details.
Thank you. So good morning, everybody. My name is Kieran Zucker. I'm a clinical oncologist based in Leeds, and I'm a clinical academic who spends his time working on health data science and machine learning engineering. I also run a consulting firm called Synaptome, focused on helping public sector organizations and startups with sort of med tech development. And what I wanted to talk today about is what I regard as data science's dirty little secret. And that is that the vast majority of projects that get published or that get launched end up going absolutely nowhere and having no benefit at all to patients in the real world, and trying to unpack that a little bit as to why that is. So with healthcare systems globally being under greater strain from issues such as multimorbidity, people having an aging population, staff shortages, and financial pressures, it's perhaps unsurprising that we've ended up in a scenario where people are looking to digital solutions to solve some of these problems. And you don't have to look very far before you start to see news articles in the mainstream media or in scientific journals talking about the potentially transformative capabilities of AI. A lot of this is incredibly positive. Some is a little bit more pessimistic, but I would say that on balance, the majority of the information that you hear about AI in health is positive, with people having a positive narrative about the benefits that this technology will have, and that comes from the media, it comes from commercial entities, it comes from government, and this is not just a UK phenomena, this is global. However, despite the fact that this is often portrayed as potentially being the magic bullet to almost any of society's ills, particularly in healthcare, the reality on the ground is very, very different. Industry estimates suggest that 85% of AI projects fail due to the issue of data bias alone. That's before you consider any other problems at all. And in fact, the rate of failure of AI-based healthcare technology implementations is twice that of non-AI-based IT implementations. So there will be people who will say, well, innovation often fails. However, the rate of failure is twice that of non-AI-based projects. And so if we think about this, in 2024 alone, this would represent £115 billion worth of wasted investment in medical AI. And that's just on the issue of bias alone. This is obviously an enormous amount of money. However, this is not just an economic problem. There are very real-world consequences for people, and when these tools are implemented and done badly, they can cause real-world harm. And the COVID-19 pandemic offers us an interesting, if painful, insight into why and how these things can and do go wrong. This is an article talking about how an automated COVID-19 detection tool was being implemented in China. And in fact, the research community, along with the clinical community during COVID-19, wanted to do what they could to try and support the pandemic response. Hospitals would provide data, they made it open source, and this ended up becoming large repositories of chest x-rays, which were then used for subsequent publications. Algorithms were put into the public domain with quotes of 98% accuracy in being able to differentiate COVID-19 pneumonia from other diagnoses. Now, I looked at this with colleagues and said, hang on a minute, does that make sense clinically? Is it plausible that from a chest x-ray alone, you can be 98% certain that something is COVID-19 and not something else? And the answer is no, that is not clinically plausible. And it turns out we were right to be skeptical. When we started to unpick the data set, the RSNA data set on which many of these were built ended up having systematic problems. This is an example, it doesn't project that well, of using GradCam on an image. What it does is it shows highlighted areas from an image which are important for a particular decision being made. Now, what you can see is at the sort of top corner, there is some text, and that text is the name of the hospital. And that is because that hospital only provided examples of pneumonia and no examples of COVID pneumonia. And so the algorithms were able to identify the name label rather than the diagnoses. Right? We also had examples of hospitals providing pediatric cases, but of course, pediatric COVID is pretty rare. So what did that mean? The algorithm could correctly identify child equals not COVID. And so when we used an unbiased data set, we found that these algorithms were no better than guessing. Now, when we curated a data set which removed these biases and we applied the methods that we used in these flagship models, they were useful, they did work, but just nowhere near as well as the original publication suggested. So one of the problems that this illustrates is the challenge of information governance. Now, information governance is critically important. It's part of the social contract that exists between clinical providers and patients, and privacy is, of course, of paramount importance. However, the way that it is interpreted and how the law is interpreted differs from place to place. So if you go to 5 different hospitals and ask, can I have such and such a data set, the process will be different, the permissions will be different, what they'll allow will be different. And what that means is that people are often reliant on building tools based on what is lying around. And this creates an environment where the Kafkaesque nightmare of getting large-scale data drives people to build products based on what is possible rather than what systems actually need, what clinicians need, and what patients need. And I'm often presented with people from industry or from academia who have built something wonderfully complicated. It looks great. They've used some fancy new model. They've applied it to some data. And I am left asking the question at the end of it, what's it for? And I'm then often met with people having created an incredibly complicated way of solving a problem that does not exist, or for which a low-tech solution already exists, or where the technology is so complicated it is not possible to implement in real-world practice. And so these are projects which, had they engaged with the right people from the outset, they could have been told that they were on a hiding to nothing. But let's ignore those problems for a second and move on to, you've built a tool and now you want to implement it. There is a tendency to think that hospitals have a highly organized data structure which underpins them. However, most of the people in this room will be well aware that that is not the case. 1 in 20 hospitals in England does not have an electronic healthcare record. 75% of those that do still rely on paper notes to some extent. And this is a reality that many companies either choose to ignore or are unaware of as an issue. So when they then come and try and implement something, they are met by the patchwork quilt of 20 years of legacy IT contracting and the messy integration that happens in the back rooms of the dusty department in the basement of the hospital. And that is then different in every hospital that they go to and ends up becoming an implementation nightmare. We also need to think about the financial implications. This article was published literally as I was writing this talk. And we have to accept the reality that the infrastructure in the NHS is in a bit of a state. And when I say infrastructure, people here may think IT infrastructure. I'm talking about the physical fabric of the buildings that people are in. We have hospitals that have large areas that are closed because they have aerated concrete. We have massive underinvestment. And in an environment in which you have organizations struggling to be able to replace the computers that are required for clinical care delivery, the idea that they're going to invest huge amounts of money in some horizon-gazing scheme on promise of economic benefits somewhere down the line simply is not a reality in which the NHS operates. And so even when you can implement it, getting somebody to stump up the money to buy one of these tools then also is incredibly difficult. But let's assume for a second that these problems have been overcome. You build a tool. Your internal validation works very well. You can integrate it into a system. It integrates beautifully, and you take the extra step of deciding you're going to monitor it for the longer term. After all, that's what the MHRA would like you to do. Sounds like a good idea. You do this, and not only is it working, it gets better over time. This is phenomenal. You pat yourself on the back, you think to yourself, job well done. The problem is, what you haven't realized is that you are perpetuating mismanagements of patients at scale in a hidden way. So how does this work? Well, this paper shows the maths of it, but I will give you a brief overview. I'm an oncologist, and I will see a new patient in my clinic. And let's say it's a clinical bias of mine that people with a particular comorbidity do badly on chemotherapy treatment. I think they get more toxicity, perhaps they don't necessarily do as well in the longer term, and so I decide I'm going to give them atypical treatment. And because I've given them atypical treatment, they don't do so well, because I haven't been as aggressive. I build an algorithm. The algorithm identifies that people with that comorbidity, diabetes, don't do so well. It therefore produces a prediction that says diabetic patients don't do well. You give that to clinicians. Clinicians choose not to give them aggressive treatment, and so they don't do well. And so the self-fulfilling prophecy continues. And so the problem is that even when you overcome all of these issues, if you don't necessarily design your algorithms in a way that takes into account these sorts of things, you can still end up doing massive harm and causing problems. So how do we stop the medical AI wild goose chase? And I would say it can be encapsulated by one phrase, which is translation by design. We need to start building models from the outset with translation in mind. It is not just an engineering problem, it is a change management problem. It is also an implementation science problem. We need to start with challenges that need solving, not the data that is available. We need to understand what limitations are for deployment when you actually get to implement a tool from the outset so that you can try and engineer solutions to that as you go. We need to ensure that all stakeholders are considered, because what is advantageous or desirable by clinicians may not be desirable by patients, and vice versa, and also all the other stakeholders in the mix. We also need to be mindful of decision makers. Internal validation is simply not enough. We need to have qualitative evaluations. We need to understand what the health economic implications are, because if you want people to pay for a tool, they need to understand what the benefits they're getting are, not just in terms of clinical effectiveness, but also in terms of how it impacts staff, how it impacts workflow, and how it impacts costs for those organizations. We also just need to stop fueling the hype machine. We need to inject a healthy dose of realism. And whilst at the moment, projects in AI in health are, relatively speaking, easy to get funded, unless we start to actually translate that into real world benefit for people, that gravy train will come to an end very quickly. Thank you very much for listening. I hope that was interesting. For those that want to connect, that's probably the easiest way of doing it, on LinkedIn. Thank you very much.
Okay, so slight change. Max couldn't make it, but Mike is here, and
Right. I will hopefully remember what I'm supposed to be saying here and make a little bit of sense. So you're probably looking at the title and you're thinking, upskilling. Okay, yeah, I know what upskilling is. That makes sense. That's training people to get more skills. Building the future. Okay, taking those upskilled people to do something useful in the future. And then you get to the digital health vegetables. You're like, how much did you drink last night? When were these slides done? We'll get to the vegetables. That will hopefully make sense. So I think we've got a problem in digital health. Well, there's many problems, but there's one problem that I want to talk about. We love digital transformation. Like, everybody does digital transformation. We take these archaic things like a paper form, and we transform it into these wonderful electronic things that are absolutely brilliant. This video is sped up, I think, 4 times, actually. And if you're paying attention, it's confusing and you're double entering data, and yeah, it's rubbish. But that's not really the problem, because that happens. The problem is we, as a collective majority, seem to accept this. We think this is as good as we're going to get. We have a kind of blindness to this. We think this is the best that you can find on the shelf. This may not be. There's slightly better things on the shelf. And this is the kind of the best compromise. And this leads to
All
things
of us might be tempted
like
to say things about Epic
video.
we would never say about a human.
Other EHRs and
The
organizations are
stupid system
available.
isn't working. I don't know what's wrong with it.
This is ridiculous. How do they expect us to work with this?
Oh, it's this new person again. You're just going to have to wait. I'm going to have to enter your information all over again.
Whoa. All that moaning and negativity is giving our patients a bad impression.
So that's a clip from a 3-minute video produced by UCLH back in 2019, I think. And it goes on to spend the rest of the 3 minutes gaslighting staff to tell them not to be honest with their patients, to ignore their duty of candor in explaining why their care is being delayed that day or why there's a problem, and making it difficult for patients to understand who or what to complain about to the trust board, to their MP. And it stifles and chills debate and discussion amongst staff about the quality of the EHR, which may be an issue with the EHR or may well actually be an issue with the deployment. And it just kind of sucks all that down and says, no, don't talk about that, you're wrong, kind of gaslights that. And that's just a very good example, but like this goes on everywhere, maybe not the gaslighting, but the kind of the not talking about it, that's the kind of the best thing that you can find. And I think this whole phenomenon really is very brilliantly captured by this quote that came up when somebody was talking about build versus buy. Sales are based on knowing no better. So if you don't know that something better exists, can't see that something better exists, never seen if something's better exists, well, we'll buy the best looking thing on the shelf. Yeah, it's a rotten tomato from 20 years ago in a rotting can, but anyway. So what do we need to do?
You mustn't be afraid to dream a little bigger, darling.
So my little clip of Inception there, which probably wasn't projecting very well, with Tom Hardy going, you mustn't be afraid to dream a little bigger. So how can we dream bigger? Well, I help do something that I think helps people dream a little bigger. You're kind of seeing that, and if you're not really familiar, you're seeing the word hack and you're thinking computers and coding and scary things and naughty things. But it's not that. It's people coming together and talking about things, discussing things, building things, presenting things. Yeah, maybe there's a little bit of scary terminal stuff. So what really is like a kind of NHS Hack Day was a weekend event where anybody turns up. So patients, social workers, doctors, academics, designers, developers, anybody really, you kind of come with a problem. I find it hard to speak to my GP. I'm a ward doctor. I find it difficult to manage patient lists on my ward, even though we've got a multi-million-pound EHR. And you say that in a 1-minute pitch, and then a group of people, whoever's there, turn up, and you talk about the problem, and you maybe approach it from a different angle, talk to somebody, see something from a different angle, think about it a little bit differently over the weekend, and then you share your learning. And maybe you've built a little prototype.
Yes.
Sorry, I'm not sure what's going on the slide there. Maybe build a little prototype. Maybe that's useful. Joe is vanished, but I found a prototype that we did build in Newcastle a couple of years ago that Joe then used as a show the thing to go around when he was responsible for the Great North Care record. And it's a useful little thing. Didn't actually do anything useful, but it was a good, here's the thing to kind of do something. And, oh no, sorry, we skipped too far ahead. You missed the thing. And
Yes. So it's
the technology. William, here is the technology. I've asked you to simply make it smaller.
okay, sir. That's what we're trying to do. But honestly, it's impossible.
Tony Stark was able to build this in a cave with a box of scraps.
so, yeah, building the thing at the weekend, I rushed and didn't really introduce myself, but anyway, it's realistically, it's not going to be a production-ready thing. There are issues, there's regulatory, there's safety, there's many things. And people, and I'm happy for it to kind of, the myth to go on, you go to one of these events, you all think, oh, I'm going to build something, it's brilliant, we'll build it over the weekend, we'll deploy it, it's perfect. That's not the secret to the event. The secret to the event is building this kind of attitude in people that turn up. That's the vegetables. It's hiding the vegetables your kids don't want to eat under the mashed potato, whatever I don't know, bad analogy, but it's making people unaware that actually they've had fun over the weekend and their attitudes have shifted. So when they go back to work, they can go, well, I did this in a weekend with a bunch of patients, designers, and other people, and build something useful. So I don't think the event is about people learning to work in a multidisciplinary team, to learn and look at problems from different perspectives, to improve presenting skills, to learn to code evenly as a kind of doctor, or to kind of build a functional prototype. The most important thing for me, and the most important learning, I think, that event and kind of things like that, is for people to learn that this is not the best that we can get. And I think I'm just under time there, but that's probably fine.
Thank you very much. I'll just stay there because we've got the Q&A session now. So, oh, hands are already flying up. So, I guess, got the mic. Do we have a mic that I can pass out? Or? Okay, cool. Okay, if you just say your name and then the question.
Hello, everybody. Thank you for this panel. I feel very represented having a computer science and engineering background in this panel, so thank you. I have a question for Kieran, but I'm happy for the other two presenters to comment on it. My name is Marjorie, by the way. I'm an associate professor in ethical AI from Sheffield Hallam University. And Kieran, what you presented is literally my research. So I look at data and bias in data, and there is no data without bias. It's impossible. So once you understand this, you can then work with the data to do something that is useful. But what I don't think the audience should take from what you said is that every single GP needs to be able to code, which is something that we discussed yesterday quite a lot. It's amazing that you do, and I'm glad there are people like you inside, on the floor, so you can show to the others that you are not like freaks. Coders are not weird people. We are fine. We are nice people. But I wonder what could be done generally in terms of education and information sharing with everybody that would enhance the meaning of treating data with respect, but understanding that they need to be able to use data, you need to have some specific criteria respected. The AI is not going to replace anyone because it's never going to be as good as a human in the way that it works. So my question is very philosophical maybe, but I don't want everybody to become coders. I want them to understand the importance and the role this technology plays. So from your point of view and then the other two, what should we all be doing to make sure that we have less, wasted resources in creating stuff that doesn't work because people just don't understand. They just want to make money and try to make money whichever way they can. But that's actually, impacting the environment more than anything. So thank you.
There's a number of answers to this. So first of all, I think that there's a problem on the industry and academic side. And that problem stems from the fact that they don't engage with clinical professionals. So I think there's been some research that's been done that shows only about 1 in 20 data science projects engages with clinical professionals. And that's almost exclusively just the validation at the end. You're not going to know where the pain points are or where the problems with the data are beyond just bias in your data set, but just in terms of what is not representative of how healthcare is delivered unless you engage with those people. Equally, you need to have people who are digitally literate enough to be able to know where the problems are. And I'm not suggesting, as you're saying, I'm not suggesting that everyone needs to learn to code. The analogy I often give is that I know enough about environmental policy and energy policy to be able to make an informed choice about what I want to do with how I lead my life, whether or not I recycle and so on. I don't need to know how to build a nuclear power station, right? And so the question is, how do you get people and the clinical workforce to that level of kind of data literacy? And I don't necessarily have an easy answer, but I think that's the sort of level that we're talking. But I think on a practical note, if you want to improve the data, you need to make it easier for clinicians to collect that data, and collecting that data can't be another form for people to fill out. I think as you kind of very elegantly demonstrated, you go from an onerous paper form to a twice as onerous digital form. That doesn't help anybody. You've got busy clinicians. You need to make it as easy as possible. And I often think that one of the things that we need to do is we need to make that data collection exercise much more integrated and simplistic and take less time. That would be massively transformative. The other things, you also need to show value to clinicians for collecting that data. The problem is we collect all of this stuff, and for most clinicians, it just feels like a pointless exercise because it doesn't relate to what they need clinically. You know, we produce a national cancer registry. An extract is produced, it gets sent off to NHS England. They produce some sort of amalgam analysis 2 years later that is out of date and so like non-granular as to be useless to people. So people are like, why do we bother? And so actually, if you gave people real-time insight from that data, people would start to go, okay, this actually adds value to me and my job and my patients. And I think you kind of, you know, if you tackle it in all those ways, I think you would get, you know, better.
Adding to that, on data collection, is this, can you hear me? Yeah. On data collection, UK GPs were the pioneers of getting this right, and that there's a reason why the GP data set in the UK is the largest and most comprehensive medical data set in the world, is because they just made that data collection part of recording the encounter itself. So clinical coding is really the key to it. So secondary care systems don't generally incorporate any form of clinical coding, whether it's, you know, SNOMED or ICD or READ codes or CTV3. These are all, you know, various different coding systems. Over the years, GP systems have been built around those. So the very first thing you do in EMIS Web, for example, is you choose a code for describing what it was that you did, kind of thing. And then you can add some free text, but essentially it means that most encounters will have at least one code with them. I mean, it's almost impossible to put in any kind of entry in a GP system without a code. And when you've got that system, you're automatically generating a huge amount of data just by seeing patients and just saying, oh yeah, sore throat. Immediately, you've now coded all those as sore throats. You can search the record and say, how many sore throats did we see? You can then go into much more detail about what you did, and you can include all that as codes as well. So it's about making good quality data, is about making it a seamless part of recording the encounter. There's a possibility that the kind of AI clinical assistant type thing that's coming through, you know, they seem to be quite good at doing this. Firstly, it's transcribing the encounter, and it's a low risk thing to do because you were there as the clinician. You can see what it transcribed and summarized, and it will suggest some codes. And I think that would be a good way to get from where we are now to like an increased amount of clinical coding. But you can't do it without codes. Natural language will not solve your problem here. It won't save the day. So there's a lot of hard work to be done in secondary care, slightly less so in general practice.
Just briefly on the learning to code bit. I completely agree. You don't need to learn to code, but we need to do better with digital upskilling, but not of the workforce, of our digital leadership. They need to understand these concepts much better, so that when these things come across their desk, they have the insight to go, no, this is absolute fiction, go away, rather than going, ooh, new shiny presentation, excellent, where do I sign?
There's a kind of noticeable absence, actually, of nerds in the NHS. Like, we are a very nerdy audience here, but you go to any of the other tech conferences, and actually it's a very low number. This is something that Kev has pointed out to me a couple of times. You don't see the nerds. This is the nerdiest it gets.
I think we've got four more questions. So make it quick.
Okay, I'll be quick and nerdy. The clinical safety case stuff was really interesting. And one of the issues with clinical safety, well, firstly, the PRSB publishes all its clinical safety cases for all of its standards on the website. Yeah, well done, well done. The other thing is that ISO has been working on assurance cases, which is a specification for how to link hazards and risks, so that you've got an algebra for saying, I've got some hazards here for this product, and I'm using this product in this context. So I want to reference the hazards in that safety case. So I would suggest if you're building something around federated safety cases, it'll be worth using the assurance case logic.
Happy to take a look. However, I refuse to pay for my standards, and ISO always.
In which case, you can just.
It's always 350 Swiss francs.
It's a well-established process, and you can find assurance cases described elsewhere.
Yeah, I mean,
freely available.
Absolutely. If the standards should be open for adoption, and so if there are open standards around it, then yes, absolutely.
Hi, Asif Shah, Deputy CCIO and CSO, South Tyneside and Sunderland. One question for Kieran and one question for Marcus. Kieran, the ICB have told us that we are deploying an AI solution, whether we like it or not, or the Trust has decided that they're going to throw some money at Ambient and we're going to deploy a trial or pilot or whatever thing that you can call it, where you can get around a clinical safety case. My question is, if you haven't got control over the deployment of something, then how can we do it safely? What sort of questions do we need to be asking in terms of the AI side of things or the data set that it's been trained on? Marcus, great talk. How can I persuade my trust so that I can do my clinical safety work in the open?
Yeah, so that is a great question, and I think something organisations are increasingly going to be grappling with. There are a number of sort of documents that have been produced by various royal colleges about sort of kind of commissioning. The RCR have done stuff. It's not specific to ambient scribes, I should say. There is some stuff that has been added into some of the MHRA guidance now around NLP. What I would say is that it's about asking questions about what it was built on, what context it was tested in, and then trying to see how well that aligns with the environment that you're going to put it into. So one of the things that we've ended up having lots of discussions about is that a lot of the ambient scribe technology is designed for two people talking, and when you then end up with multiple people talking, it does a really terrible job. So the place where this does really badly is multidisciplinary team meetings, where you've got a mixture of people who are like 5 people in the room, 6 people online. It's trying to work out who is who, come up with a summary, and it often gets stuff quite wrong in that context because it was designed for a clinician and a patient sat in a room, and therefore you're moving it into a different context. I think the other thing is that it's also about having really robust validation exercises locally where you kind of design almost places where you feel like it's going to fall flat on its face and see whether or not it does. But I think the other thing also is that if ultimately stuff is being foisted upon you, I would have a significant amount of pushback with those people and say, what is it that in hand with that you are providing to give us the assurances? One of the big concerns I have about the ambient scribe technology is people present this as being a cost saving, and I suspect it will end up saving no money at all. The Health Foundation did some research at the tail end of last year where they asked the question of clinicians, if we gave you an hour back of time, what would you do with it? And only 29% of people said that they would reuse it for clinical purposes. So the problem is most clinicians work way beyond their contracted hours. So if you save people a bit of time, you can't repurpose that for clinical effective delivery. So there are only a very limited number of places where that works. So A&E, in real time, if you say 45 minutes, that's another patient or 2 you can see. Arguably, maybe general practice, that is also true. But if I'm in an outpatient clinic, if you save me 30 minutes, I can't just suddenly whip up another patient in my oncology clinic to see. So there is no health economic benefit for the organisation that are paying for it directly. Now, you might argue it helps with burnout and various other things that might actually have benefits. However, the evidence for that simply doesn't exist. So I'm always slightly sceptical because, I mean, do you have an idea of how much they're paying? Yeah. No. Yeah, so I would definitely say there needs to be something, around testing it in, multiple people, different accents. Again, I don't know how well some of these tools work with different regional accents, and what about if you've got someone who's not speaking English and you're using an interpreter. Again, I don't know how well that works. So there's all sorts of complexity, but it's difficult, and doing it well is hard. And so I would probably say that if you don't have people locally who have expertise in this, one of the things you should be advocating for is that you should get in expertise from elsewhere for people who can help you with those sorts of validation exercises.
And I'd say, ask them, is this a class 2 medical device? No, we're not going to take it then. I don't care what the NHSE letter says. It's not safe. But nobody will listen to that. That's just my troublemaking 2 cents.
So your question about how do you get your clinical safety team to adopt a more open approach? Oh, you're the clinical safety team. So, well, it might be easier then. I was going to say, it very much depends on your clinical safety officer and how much appetite they've got for that slightly techie workflow. With the benefits that you get in terms of version control and some of the things that are out of the box kind of thing. At the moment, I think it's quite a steep learning curve, and it would be a big ask for a lot of people. Being more open with the clinical safety cases you've got, that's something you can do anytime, really. You could just start publishing them on the Trust's internet site. But I accept that that's quite hard for people to do, because if things aren't born in the open, it's quite difficult to take a document that was born in a closed environment and suddenly flick a switch and make it open, because everybody's concerned that somewhere in there will be a bit of information that you wish you hadn't put into the public domain. So at this stage, I think it's quite a steep road. If you've got the technical appetite for it and you want to learn about it, I can show you. What I'd like to do is make it easier, and I think the tipping point will come when it's much easier to get other people's clinical safety cases inside either an open platform where everybody's clinical safety cases are open, or accepting that not everybody is going to open their clinical safety cases. That tour of a platform that we talked about will have a mixed economy. So the free accounts will force you to have an open clinical safety case. The paid accounts, you can have some private ones, a bit like GitHub did in the early days. But that means that everybody in there can see each other's clinical safety cases inside a walled garden sort of thing. And if you've got 50 pieces of software that you need a clinical safety case for, and you can get most of them from inside there, you've now reduced the amount of work that the team has to do drastically. That's when it starts to tip into the favor of doing it this way. At the moment, this is the hard way.
I mean, if you want help in getting things in the open, you can ask a friend to FOI your trust for all its clinical safety cases, and do it through what they know, and they'll be in the open, and you can have a clean conscience there that you've not published something that you might get into trouble for. I mean, if somebody's got time, go fill in the FOI requests.
But they will refuse quite a few of them on the grounds of commercial sensitivity, which is an allowable excuse. Well, it's an allowable excuse in the legislation. I don't think, in context, I don't think it is allowable, but that's my opinion.
I mean, we can try and take one and appeal it to the IOC and things, but anyway.
If we go back sort of 40 years or so, and consider the original motivation of things like read codes, that was actually because doctors couldn't type.
That is true, and it was also because a read code originally took up like 4 bytes, the first version. So it reduced what might have been a very long clinical rubric down to 4 bytes, and you could save a lot of disk space. Now we don't have to worry about that, but we have to worry about data quality instead. So it's still a good idea to have those coding systems. But the problem we have now is that SNOMED is the dominant standard, and it is not an open standard. And so we actually need an open terminology in order to be able to fix that.
Okay, I'm sorry for the people who didn't get to your questions. There was a lot, it was very interesting, but we are well into our coffee break now, so I'm sure the 3 people will still be around, so you can ask them the questions during that. Okay.